Okay, next topics uh, section 8.2, estimating population mean. The population mean, do you guys remember that was the symbol for population mean we use in the previous section? I think in chapter 8. What is this population mean symbols? If you don't remember, I'm going to write it down for you. All right. The population mean, we are an estimate. Why do you want to estimate population mean? Because you don't know about the population mean. Therefore, I'm going to write the symbols here for population mean. Symbol is mu. Okay, that's the population mean, and this is called unknown parameter. Unknown parameter. Again, I want you guys to check with the notes, which side by side comparison that I sent it to you guys. Okay, the population mean is mu, which is unknown parameter. We want to estimate this, right? We want to estimate mu, population parameter, because we don't know that, right? And now we use x bar, which is called sample mean. Okay, sample mean. All right, and then sample mean is also called point estimate. Because we want to estimate the population mean with the help of sample mean, which is x bar, and x bar is called point estimate. Why is it called point estimate? Because we want to estimate mu with the help of x bar, which is sample mean. Therefore, we call x bar as a point estimate. It's like a p-hat. If you look at the previous section, it's like p-hat. Remember that p-hat also called point estimate because we estimate p with the help of p-hat. Okay. All right. Now in this section we use new word or new terminology. It's called degree of freedom. The degree of freedom, short form DF. The calculator has an option DF for degree of freedom, and to find the degree of freedom you have to do is n-1. If you subtract 1 from sample size, again you know n equals to sample size, obviously everybody know that, sample size, you'll find degree of freedom. Or n equals to degree of freedom plus 1, just same thing but other way around. Either you call degree of freedom equals to n-1 or n equals to degree of freedom plus 1. Okay, we use these two formula here in this section, either to find degree of freedom, to find the n using degree of freedom. That's the formula. Again, what's the degree of freedom? If you subtract 1 from sample size, you get degree of freedom, or if you add 1 to the degree of freedom, you get sample size. Okay, now there is a two formula or calculator function we use to find critical value. This is similar to previous section. We will find the critical value, but if you remember the last section 9.1, z alpha over 2 is critical value. But in this section we use critical value as t alpha over 2. When you estimate population mean, we use t alpha over 2 as a critical value, and we call this critical value for t. That's we call critical value for t. Okay, not just critical value, but we call critical value for t. You can see here critical value for t and critical value for t. And there is two scenario in this question. You can find the critical value either if confidence level is given. Look at here. If area is given, we'll find the critical value. And if confidence level is given, find the critical value. Therefore, there's two way you can find the critical value if area is given or confidence level is given. Okay. All right. Therefore, let me write down the both function in the calculator. And here is the function t alpha over 2 equals to int t. I'm going to show you what's that in the calculator. Int t C level. I'm sorry, not C level. This is left area of a left area here. Left area because area is given. Left area, comma, degree of freedom. Again, I'm going to show you how we put that in the calculator. That's the formula to find the critical value if area is given. Listen, sometimes they give you left area, you got to find the right area. Oh, sorry, sometimes they give you the right area, you got to find the left area. If left area is given, you're good. That's the function. But if confidence level is given, the critical value formula is going to be int t confidence level plus alpha over 2 comma degree of freedom. Again, confidence level plus alpha over 2. What is alpha? We did in the previous section. If you know confidence level, alpha is given. You can find that. For example, let's say for 90% confidence level, alpha going to be 0.10. You know that, right? Therefore, as long as you have a confidence level, you can find the alpha. And that's how you find the critical value using calculator function here. And some of the calculator function doesn't have int t. Okay, don't you have int t option in the calculator? If you have no int t option in the calculator, you got to follow this to find the critical value. Okay, I don't know how many of you have a int t in the calculator. If not, you got to use this method or this steps to find the critical value. Okay, I hope everybody has int t. Let me go back and show you whether you can find the int t option to find the critical value. Okay, okay, to find int t, you just press like when you find normal CDF, you press second VARS number 4. See, that's the int t. Okay, remember that in norm we used in the last section to find the critical value, but if you estimate population mean, we use int t to find the critical value for t. Okay, therefore number 4 has to be option under this distribution. Okay, do you guys have int t in the calculator? You double check it. If not, you have to follow this steps to find the critical value. Okay, let me do the question number 1 first. The critical value for t for a 90% confidence level with degree of freedom 109. Okay, now let's do question number 1. Here, critical value for t, let's find that critical value for t, that is find t alpha over 2, right? Critical value for t, that means t alpha over 2. Find that with 90% confidence. I should say confidence level, not the interval. Confidence level, 90% confidence, 90% confidence level. Okay, now a confidence level is 90%. Therefore, C level here, C level equals to 90%, 90%, which is same as 0.90. What's the alpha? The alpha gonna be 1 minus C label. Do you remember from the chapter 9 section 9.1? 1 minus 0.90 equals to 0.10, right? That's the confidence level. Oh, sorry, that's the alpha. Okay, now to find the critical value, you have to use this for this function, second function. Let's put that in the calculator. Let's write down first. T alpha over 2 equals to int t C label is 0.90 plus 0.10 divided by 2, comma, degree of freedom is 109. Watch. You guys watch this steps here. I use the second function here to find critical value for t. In t 0.90, because this confidence level is 90%, is 0.90. You have to use decimal. Plus alpha is 0.10 divided by 2. That's the formula, comma, degree of freedom. Let me put that in the calculator. I can put all at the same time like this. Watch. Again, how do you find it? You go to the second BARS number 4, which is empty. Okay, now start parenthesis. You put that whole thing here. You put that under the area. Okay, under the area, and you put 0.90 plus 0.10 divided by 2. Okay, I put exactly like that as a area, comma, 109, parenthesis close. That's what you do. But if you have an option with the left area, if you have an option with the area and you say left, choose the area and choose the left. Type this area, choose the left. Therefore, I want to say, if you have the option with to type the area, put this under the area and choose left. Choose left option. I don't know which calculator you have it. Then you'll get the answer, and that's, let's see, the answer going to be 0.1658. Okay, 1658. If you round it to decimal, going to be 0.166. 1.166. Sorry, 1.66, not 160. 1.66. Let's check back again. 1.66. Okay, this 5 rounded to 6. That's the critical value if confidence level is given. Okay. Question number 2. Find the critical value of t such that the area on the right tail is 0.02. Area on the right is 0.02, right? But in the formula, if you remember that, if area is given, you have to use the left area. But this question, you have a right area is given on the tail. If you have a right area is given, what do you guys think left area going to be? In this question, left area, that's what I need. 1 minus 0.02, which is going to be 0.98. Okay, again, some of calculator has always area option and the right option, you good. If some of calculator has, like mine here, doesn't have a area option and the right option, by the time I got to do this to find this, I do this empty, left area is 0.98, comma, 19. Notice that 19 is a degree of freedom, which is 19. Therefore, I use 19 here. That's the critical value. And let's do the calculator. You guys would do with me at the same time and see how it works. You do second BARS number 4 in T, and you type 0.98 comma, the degree of freedom here is 19, and close parenthesis, you get 2.204. And if you round it to 2 decimal or 3 decimal, depends on the instruction, 2.205 if you round to 3 decimal. Okay, 2.205 rounded 3 decimal places. Depends. Okay, what's 1 decimal places, it depends. Okay, down to 3 decimal. Make sense to you guys? Everybody get this answer? Verify this answer. Okay, so far we did is to find the critical value for t, right? That's all we did, to find the critical value for t. We need that critical value in this section, therefore that's very important. How do you find the critical value for t? Use in t option to find the critical value for t, and this is for estimating population mean. Okay, all right, now let's talk about confidence interval stuffs here. Let me start with the some symbols. Sample standard deviation. Sample standard deviation symbols is, what do you guys think? Sample standard deviation symbol, do you remember from the chapter 3? Sample standard deviation is S. Okay, we use S as a sample standard deviation, or S of X, the same thing. In the calculator has S of X, or S, or S of X. That's the sample standard deviation, whether you call S or S of X, the same thing. Sample mean, already mentioned, that is X bar. Sample mean is X bar. Okay, again, what is X bar? Another name for X bar is called point estimate. Remember that. Point estimate is also name for X bar. Point estimate. Okay, and the margin of error for mean, margin of error as the symbols E, we did that before. Margin of error E as a symbol. We have the formula for that. Margin of error formula is T alpha over 2. Again, T alpha over 2 you can find using the calculator like before. Remember that T alpha over 2, we know how to find T alpha over 2. That's the critical value for T. T alpha 2 times S divided by square root of n. That's the formula for margin of error. Okay, again, you see carefully. E equals to T alpha over 2 times S over square root of n, or E equals to upper bound plus lower bound divided by 2, or E equals to upper bound plus lower bound divided by 2. Oh, sorry, minus, my bad, minus. It's minus. Upper bound minus lower bound divided by 2. Okay, notice that I'm talking about the confidence interval here. The confidence interval is going to be two numbers, upper bound, lower bound first, lower bound and upper bound, and this number in the middle, this is called X bar, the point estimate. X bar is halfway through upper bound and lower bound. Okay, I use UV for upper bound, LB for lower bound as before, right? LB for lower bound, UV for, this is the point estimate half. And from here to here, this is called margin of error. The red one, red length here, called margin of error. This is called E, margin of error. Okay, and to find the E, you subtract upper bound and lower bound, divide by 2 to get the margin of error, or use this formula. And you might thinking, hey, which formula am I going to use? Look at the question carefully. Whatever question asks you to use it, use the formula correctly. Okay, And here I'm going to write something here. Also, to find x bar, sometimes we use upper bound plus lower bound divided by 2. Okay, that's the formula for point estimate. To find the x bar, you use upper bound add with the lower bound divided by 2 to get point estimate x bar. Okay, all right, and this is called confidence interval for a mean. And I should say this interval, this confidence interval, interval for mean, I should say population mean, right? Population mean is center at x bar. In other words, this interval has a middle points which is x bar, and the population mean is somewhere here in that interval. Could be bigger than x bar, could be smaller than x bar, but it's going to be in that interval. In other words, the population mean, we can estimate that, and we say, hey, the population mean is in between these two number, lower bound and upper bound. Okay, now we construct the confidence interval using either formula or calculator function. I'm going to do both. Let's do formula first. Okay, a lower bound is going to be x bar minus e, upper bound is going to be x bar plus e, and together we call x bar plus minus e. That's the confidence interval. X bar, hold on a second, x bar plus minus e, x bar plus minus e. That's the confidence interval. This is like a format of the confidence interval. Okay, this is the one format, x bar plus minus e. That's the one format of the confidence interval. Okay, let me circle that. Or other format could be this. Other format could be, it's not responding here. Wait for that to be. Other format could be x bar minus e comma x bar plus e as an interval. That's the another format. You see different format of the confidence interval in the homework. Therefore, I'm writing a possible format you'll see in the homework. I should say x bar here. Therefore, other format going to be x bar minus e comma x bar plus e. Basically, x bar minus e is what? Lower bound, comma x bar plus e is upper bound, right? Lower bound, comma upper bound. Or other format going to be like that. X bar minus e less than mu less than x bar plus e. This is another format as an inequality. Therefore, in the homework or quizzes, you can see either format, either x bar plus minus e format or x bar minus e comma x bar plus e in the parenthesis format, or x bar minus e less than mu less than x bar plus e inequality format. These all are, these all are confidence interval for population mean. Okay, Okay, and these all format are called confidence interval for population mean. It doesn't matter what format, is going to be the same interval. Okay, now let's do the question number 3. um, Here this question is about finding confidence interval for population mean. Okay, that's the question. In a random sample of 100 audited state tax return, this that's 100 is here is a sample, n equals to 100. It was determined that mean amount of additional tax owed was 3,454. That's the mean of those 100 audited state tax return. Therefore, x bar here equals to 3454 because that's the mean. Remember that mean of those 100 audited tax return, and standard deviation of those 100 audited tax return is 2,550. That's the SX. That's the standard deviation for the sample, which is going to be 2,550. Okay, now construct and interpret 90% confidence interval for the mean additional amount of tax owed for state return. Okay, and the first question is verify the requirement for the constructing confidence interval about the population mean are satisfied. And here requirement is sample size. Look at the sample size. If sample size n equals to 100, which is greater than 30, as long as sample size greater than 30, the requirement can be satisfied. If sample size is not greater than 30, if sample size is not greater than 30, sample size is less than 30, then the population must be normal. Okay, population must be normal. But here we don't know is the population is normal or not normal. Therefore, we must have sample size greater than 30. Therefore, in this case, the requirement is satisfied. Make sense? All right. Now, identify the point estimate for the population mean. And notice that I mentioned before the point estimate is also called X bar. See, I mentioned that before. X bar is called sample mean, also called point estimate. Therefore, here X bar is the point estimate is sample mean, which is 3,454. Okay, that's the point estimate. Find the margin of error. That's the next question. Okay, to find the margin of error, you have to use the formula over here, because this formula E has T alpha over 2 critical value, standard deviation for sample, and sample size, right? But you have another formula for margin of error, but you cannot use this because you don't have upper bound and lower bound. Actually, we are looking for upper bound and lower bound. Therefore, we use this formula for E to find the margin of error. Therefore, E equals to T alpha over 2 S over square root of n. That's the formula. Okay. All right. To find E, we need critical value for T. Again, how do you find the critical value for T? We did that in question number 1. Critical value for T, if you have a confidence level is given. Here, for this question, the confidence level is 90%. See, 90% confidence level. Therefore, for 90% confidence level, what is the critical value for T? That's the question. And then I will find the margin of error. Okay. For 90% confidence level, what is T alpha over 2? That's what I'm looking for. How do you find it? This is exactly same as question number 1, but we have different degree of freedom. And notice that n equals to 100. For degree of freedom, going to be 100 minus 1 equals to 99, because the formula here for n equals degree of freedom, sorry, degree of freedom equals n minus 1. Therefore, I use that n minus 1 as degree of freedom to get 99 as a degree of freedom. Okay, now let's find T alpha over 2. T alpha over 2 gonna be empty, and what's the formula again? I mean calculator function here, C label plus alpha over 2 comma df. Okay, what is C label here? C label here is 0.90 plus alpha is 0.10 divided by 2 comma 99. Okay, notice that for C label 90, alpha going to be 0.10, and this is the area on the left. This is the left area. If you have a calculator that asks you find the area, put that under the area and choose the left. Okay, and let's do that in the calculator. Here you go, that's the calculator, and let's do empty. Second BRS number 4 is empty. Okay, and 0.90 plus 0.10 divided by 2 comma 99 close parenthesis, enter. You get 1.66039. For I rounded to 2 decimal, 1.66. For critical value is 1.66 here. Now let's put that in the, let's put this value into the formula. Okay, 1.66 times S here is 2550. You can see over here, divided by square root of 100. Makes sense? All right, and if you do the math here, what's the value of this guy going to be? 1.66 times 2250 divided by 10. Oh, my bad. This is 2550. Okay, let's put that 2550. 2550. Now let's simplify this, and 2550 divided by 10 is 22055. So obviously let's do it. Okay, and multiply this by 1.66. 1.66, that's the 423.30. Therefore this number is going to be 423.30. that's the margin of error. Okay, that's how you find it, margin of error. All right, now construct and interpret 90% confidence interval for the population mean. Okay, now remember that confidence interval has to have lower bound and upper bound. Lower bound is x bar minus e, upper bound is x bar plus e. I'm going to use that because I have a x bar and I have a e. Therefore I'm going to use upper bound as x bar plus e, which is going to be 3454 plus 423.30. okay, and lower bound going to be x bar minus e, which is going to be 3454 minus 423.30. and if you add x bar plus e, you get okay, if you add 3454 plus 423.30, I did here, you get 3877.30, and if you subtract these two numbers, you get 3030.70. okay, therefore you guys see that the confidence interval for the population mean is going to be 3877.30 comma 3030 comma 70. okay, that's the one answer. And another way you can write the confidence interval going to be this, x bar plus minus e. Therefore you can do either this way, 3454 plus minus 423.30 in that format, because notice that this is the x bar, this is the e. Therefore you might have this format for the confidence interval rather than this one, or other format could be like this. You have lower bound. Oh, I'm sorry, I have to switch this order, okay, because the lower bound comes first. Therefore I'm switching this on the order of the number. All right, my bad, 3030.70 comma 3877 comma 30, because this the lower bound first comma upper bound next to the parenthesis. As an inequality, you can write this: lower bound less than mu, that's the population mean, okay, population mean, less than upper bound 3877.30, and that's another format. Therefore you guys notice that you have this all different format for confidence interval. Either you get this way or that way is the same answer. Okay, that's the construct. Again, we can do that using the calculator. Let me show you how to find the calculator. You have to do this. Okay, you guys go to the stat and you guys go to the test and you choose number 8. Okay, be careful, number 8. I can scroll down, number 8, which gonna, let's see, t interval, that's the number 8. Let me select number 8 as t interval, enter. Then you have data and stat, two options here. But since we have a stat, we select start here. It should be highlighted and enter. Then this option pops up. Okay, again in number 8 you select you select starts and you put the data x bar here. What's the x bar value we have before? 3454. That's the x bar, 3454. What's the sample standard deviation? Sample standard deviation gonna be, let's see, what is sample standard deviation? 2550, right? 2550. Let's put that here, 2550. And what's the n? N is 100. That's the 100 sample. Confidence level is 90%, 0.90. And calculate, and you get, let's see, 3030.6, okay, and 3877.4. exactly similar, not exactly the same, but you can hear 3030.70, but you have a 6 here. But if you the homework is just little 0.1 error tolerate, okay, you good. Another one with 3877.30, and in homework that error going to be tolerated, you good. That's how you find the confidence interval for population mean, okay, using calculator. All right, now next question is interpretation. I'm going to interpret here for this question. interpretation. Interpretation for this particular question. What do you mean by 90% confidence interval? That means we can put it this way: one can be 90% confidence that the mean additional tax O is between $3,030.70 and $3,877.30. Okay, that's the interpretation. Okay, all right, that's all about this question number 3. Question number 4. A simple random sample of size n is drawn. The sample mean x bar is found to be 35.1 and sample standard deviation s is found to be 8.7. okay, that's the mean and the standard deviation of the sample of size n. But n here is different question. You see that n equals to 40 here in part A, n equals to 100 here in part B, and so on. And you have like 4 different part of this question, number 4. First question, construct a 90% confidence interval for mu if the sample size n is 40. Here in this question n equals to 40 and confidence level we call C level equals to 90%. As a decimal you can write 0.90. Okay, and you have to construct a 90% confidence interval in this case for sample size 40. Okay, to do that we use a calculator. We can do manually like we did in question number 3 here, like this way, or you can use calculator to find the confidence interval. The calculator is this. You do start and you should click test here and find number 8. T interval. Okay, T interval, and you choose start. Okay, if you choose start, you have a the place you can put the X bar, and here X bar is 35.1, 35.1. Put 35.1 here again, 35.1, and the SX is same as S, which is standard deviation 8.7, and sample size here is 40. Okay, 40. Then put 40 here, and you get, you have to put confidence level as a decimal, which is 0.90. We'll have 0.9 for you, good, and you highlight calculate and just press enter, and you see the confidence interval here for the mean with sample size 40 is 32.78 comma 37.42 if we round it to 2 decimal places. Let me write down the interval. The interval gonna be 32.78 comma 37.42. Okay, that's the confidence interval for sample size n equals to 40 when confidence level is 90%. Okay, now for part B, you do the same thing. Construct 90% confidence interval if the sample size is 100. You see that? Part A and part B, the difference is sample size. And you do exactly the same thing. Let's do that in the calculator. Again, you get a start, test, number 8, which is going to call T interval, and you have to select start since you have already selected, and you choose put X bar, that's already there, XX, which is standard deviation for the sample, already there, but you choose n as 100. You type 100 for n, and confidence level is again same 0.90 or 90%, and the calculate, and you get confidence interval with 33.66 if you round it to decimal, comma 36.55, right? 555. Therefore, the confidence level, interval in this case is 33.66, comma 36.55. Okay. All right. And the second part is, how does increasing sample size affect the margin of error? What happens here? Your sample size increased from 40 to 100, but we keep the confidence level 90%. And the question is asking, what happens if you increase the margin of error? Okay, that's the question. All right, let's find the margin of error in each case. What's the margin of error here? In this case, margin of error is upper bound minus lower bound divided by 2. Okay, let's do that. What's upper bound? 37.42. 37.42 minus 32.78 divided by 2. Okay, if you do the calculator, okay, and I did that for you, and I get 2.32 for this margin of error, 2.32. For here, margin of error in this case gonna be 2.32. What's the margin of error for this sample size 100? Let's find that. E is same as 36.55 minus 33.66 divided by 2, and if you subtract and divide by 2, that's the margin of error. I already did that for you. 36.55 minus 33.66 divided by 2 gives you 1.445. Okay, 1.445. Makes sense? 1.445. Double check. 445. And what happens is here, let me write down the margin of error here, is 1.445. What happens in this case here is, as we increase the sample size, the margin of error decreases. Therefore, what's the conclusion here? And the conclusion is increasing sample size decreases the margin of error. What happens is, if you decrease the margin of error, note that if you decrease the margin of error, if we decrease margin of error, the interval, the confidence interval becomes narrower. Okay, the another way to see it, let me just draw the kind of picture for you. This is, let's say this is the point estimate, this is the interval, okay, let's say, and this is the margin of error. Okay, whatever here, that's the margin of error. Okay, now if you decrease margin of error, let's say you have the same point estimate, but if you decrease the margin of error, let's say now the margin of error is just that. Okay, and look at the confidence interval. This is the confidence interval, and this is the confidence interval. For the same point estimate, remember that both center at the same point estimate, but this interval going to be narrower than this confidence interval. Therefore, by decreasing margin of error, you narrow the confidence interval. That means confidence interval becomes smaller. You see that, right? That's what we say here. Okay, question number C. I'll just erase this one. Maybe I need another thing to write down here. Part C. Construct 98% confidence interval for mu if the sample size is 40. You do the exactly same as before, but you choose sample size 40 and interval 98%. Again, you do in the calculator, and you'll find that the confidence interval going to be this 31.76. That's the lower bound. Upper bound must be 38.44. Okay, the for 98% and n equals to 40. Okay, and what's the margin of error in this case? Let's find the margin of error, because I got to answer how does increasing level of confidence affect the margin of error. You compare with the part A. Remember that part A we use 40 sample size, and part C we also use 40 sample size, but we increase the confidence level, right, from 90 to 98. In other words, by increasing level of confidence from 90 to 98, how margin of error is affected. That's what I'm going to do. And I'm going to find the margin of error here as well. 38.44 minus 31.76 divided by 2. Again, margin of error formula is upper bound minus lower bound divided by 2. Okay, let me do that for you. 38.44 minus 31.76. That's, you get it, divided by 2, you get 3.34. That's the margin of error. Now if you compare this margin of error with this margin of error, what happens? The margin of error is more. Therefore the question is, how does confidence level affect the margin of error? Is as confidence level increases, margin of error also increases, right? You see that 2.32 was margin of error with 90% confidence for sample size 40, but if we increase to 98% with the same sample size, the margin of error going to be larger. Therefore, as confidence level increases, margin of error also increases. In other word, confidence interval becomes wider. Means you have a bigger interval. If you increase confidence level with the same sample size, your confidence interval becomes bigger or wider. Okay, part D. If the sample size is 18, what condition must be satisfied to compute the confidence interval? If sample size 18, that means sample size less than 30. Since n equals to 18 is less than 30, the population must be normal to compute the confidence interval. Okay, otherwise, remember that in the previous case sample size is what? 40, 100, 40. Therefore sample size greater than 30, you don't have to have a population normal. If sample size is 18 less than 30, by the time the population must be normal to construct confidence interval. Okay, therefore the question is, if the sample size 18, what condition must be satisfied? In other words, if sample size is less than 30, the population must be normal to compute the confidence interval. Make sense? Okay, now last question here, determining sample size. I'm going to erase this one here, and we have just one formula here. The formula here is n equals to z alpha over 2 times ss, which is sample standard deviation, over e to the power second. That is the formula to find how much sample size needed to estimate population mean. That's the formula. Okay, that's the formula to determining the sample size. Question number 5. That's what we're going to use a formula. A doctor wants to estimate the mean HDL cholesterol of all 20 to 29 years old female. That means doctor wanted to determine the mean cholesterol level of the population, all 20 to 29 years old female is the population. How many subjects are needed to estimate the mean HDL cholesterol within 4 points with 99% confidence? That's the question. How many subjects are needed? That means how many sample size are required? Here n equals to how many? That's what we're looking for. Therefore, I'm looking for sample size. But given 4 points within, that means 4 points is margin of error. 4 points margin of error with 99% confidence. Therefore, confidence level is 99%. Confidence level is 99%. And assuming S equals to 19.9, S equals to 19.9. Okay, based on the earlier studies. That's why looking for sample size. Let's do this first part before this question mark. Okay, what I'm looking for, sample size for 99% confidence level with standard deviation 19.9. Okay, to find the sample size, we use this formula: n equals to z alpha over 2 times times s divided by e times s divided by e to the power second. But we have everything except critical value here, and my question is, what is critical value for 99% confidence, and what is g alpha over 2 for 99%? What is that? In other words, for 99% confidence level, what's the critical value? We did in 9.1, and you notice that for 99% confidence level, critical value is 2.576. Therefore, I'm going to use that critical value in this case, which is 2.576 for critical value for 99% confidence. I'm going to use that 2.576 times S is 19.9 divided by margin of error is 4. Remember, the 4 points, not the 4%. I use just 4 to the power second. Okay, let's do that in the calculator. Let's do everything in the calculator. Let's see what you get. Let me do that for you. This way. Let me just parenthesis start here. 2.576 times 19.9 and divided by 4 to the power second. Okay, and that's you get is 164.23. Okay, and remember that you always round it up to the nearest whole number. This is going to be 165. Therefore, here sample size required is 165. Again, you got to always round it up. Round up to the nearest integer or whole number. That is 165. Again, doesn't matter whatever number after decimal. This is going to be one more. 164 becomes 165. Okay, similarly, other part here, let me highlight that part. Suppose the doctor would be content with 90% with the confidence. How does, okay, for again looking for sample size with 90% confidence in this case, and we're looking for n with 90% confidence, and again with 90% confidence level, what's the critical value? We need that again, and we have this again, we found it before in 9.1. for 90% confidence level, critical value is 1.645. I'm going to use that number, 1.645. 1.645. Okay, let's use that one in the formula. N equals to z alpha over 2 times s divided by e to the power second. We get 1.645 times s going to be 19.9 divided by 4 points and square of that. Let's put the calculator. Exactly same way we did before. Start parenthesis 1.645 times 19.9 divided by 4, close parenthesis, square of that. You get 66.97. This gonna give you 67. Therefore, this is 67 when you round it the whole number. Okay, and the question is this: you have 165 with n equals to with 99% confidence level. We have 67 with 90% confidence level, and the question asks you, how does decrease in the confidence level affect the sample size required? Listen, if you decrease the um, um, confidence level, sample size required going to be decreases. That means for smaller confidence level, smaller sample size required. Then how do you write the answer? As we decrease, as you decrease the confidence level, we require smaller sample size. Require the sample size. And you see that here. Again, 165 sample size required for 99% confidence level. 67 sample size required for 90% confidence level. Therefore, as you decreased the confidence level, the sample size required going to be decreases. That means we need less sample size for smaller confidence level. Okay, that's pretty much 9.2. And you have a note here. This note is already explained before in previous example and this example. You guys can read yourself. That's all about this section 9.2 handout. Thank you for watching the video.